All right, let's do some more rambling here about this idea of correlation, and that correlation does not make causation. So just because we graph two variables together and they come out looking kind of linear, then that doesn't necessarily mean that there's causation. For example, here, uh, looking at this right here, my two variables are fresh lemons imported to the USA from Mexico in metric tons, and total U.S. highway fatality rate. So in other words, this is a rate, probably like this represents 16% of people our car accidents are fatal. And so what this graph is saying is that they are negatively correlated, which means that as we import more lemons, the fatality rate's going to go down. Now we all realize that those two variables have nothing to do with each other, even though they are said to have a strong correlation. If you look up here, this r squared value is very close to 1, and that means that if those dots lined up perfectly, then that value would be 1 in particular. Now, would be 1. And then here's, you guys can read this comic here for a little bit. So another huge study found no evidence that cell phone cause cancer. What was the WHO thinking? I think they just got it backwards. What? So this graph shows total cancer incidence, and then after the total cancer happens, the cell phones rise. And there's a lot of issues with this problem. As he says, there are so many problems with that. Just to be safe until I see more data, I'm going to assume cancer causes cell phones. So the point is, correlation, just because things both go up at the same time or go down at the same time, does not mean that they're caused. But let's look at what these assignments look like in the ALEKS assignment. And we can have relationships that are nonlinear, like this one here, right? And we can have relationships, this would have a very low correlation value, close to 0, right? And this one has a positive correlation, and this one has a negative correlation. Not that it's bad, it's just that as one increases, the other one decreases. And this is a positive correlation where as X increases, Y increases also. So as we fill this out, which data sets appears to have a nonlinear data set? We would say figure 1. Which data set appears to show a positive linear relationship? That would be this one, because it's going up. So we would say data set 3. Which one appears to have a negative linear relationship? In other words, it's going down. Then that would be figure 4. And then which data sets happens to have no relationship? That would be that one right there. Anyway, I hope this helps with filling out part of the thing, a Maduger. Anyway, have a good day. Talk to you later.